What is our purpose in this vast cosmos? In the intellectual ferment of ancient Greece, Aristotle, a figure of monumental intellect and foresight, stood as a beacon of inquiry and wisdom. His thoughts, deeply etched into the annals of philosophy, reached forward into the future, influencing generations to come. Chapter 1: The Inquisitive Dawn. Within the hallowed halls of the Lyceum, surrounded by the verdant rustling of olive trees and the eager minds of his disciples, Aristotle pondered deeply on the existential questions that have long perplexed humanity. Central to his contemplations was the concept of telos, a revolutionary idea proposing that every entity, every aspect of the natural world, possesses an intrinsic purpose. This daring philosophical leap was more than mere speculation. It was an attempt to decipher the fabric of the cosmos itself. He postulated that everything from the gentle descent of an autumn leaf to the universal dance of planets followed an inherent design, a purpose woven into their very existence. Aristotle's teachings, preserved and propagated by his followers, laid the foundational stones for centuries of philosophical and scientific exploration. They spurred a quest to understand not just the mechanics of nature, but also the underlying intentions of the cosmos. Aristotle's legacy, a blend of keen observation and profound thought, permeated through the ages, shaping the contours of human understanding. His concept of telos provided a framework that guided thinkers and scientists as they navigated the complex labyrinth of existence. The idea that everything in the universe, from the smallest particle to the most massive star, is part of a grander scheme, imbued with purpose, resonated through the centuries. It inspired generations of philosophers, artists, and scientists to seek out the hidden purposes of the natural world, to unravel the mysteries shrouded in the cosmos. This philosophical perspective did not merely seek to understand the how of things, but delved deeper into the why, the underlying reasons that propelled the universe's ceaseless motion. Aristotle's teachings, steeped in the quest for purpose, became a cornerstone, an intellectual bedrock upon which the edifice of modern thought and scientific inquiry was constructed. The ripples of his thoughts on telos have echoed through time, influencing our ongoing search for meaning in the vast, uncharted expanse of the cosmos. The saga of human understanding underwent a profound transformation with the advent of Galileo Galilei, an individual whose fate was remarkably entwined with the celestial bodies he so ardently studied. In the early 17th century, Galileo, equipped with a telescope crafted by his own hands, turned his gaze skyward, daring to question the long-standing geocentric beliefs that had dominated since the days of Aristotle. This was a period marked by intellectual rigidity, where the Earth's central position in the universe was an unassailable truth, rooted deeply in both scientific and religious dogma. Galileo's telescope, a humble yet revolutionary instrument, became his conduit to the stars and his challenge to the status quo. Through this lens, he observed phenomena never before seen by human eyes: the rugged craters of the moon, the 4 major moons orbiting Jupiter, and the changing phases of Venus. These were not just mere observations. They were radical revelations that upended centuries of established thought. Galileo's discoveries transcended the realm of mere scientific curiosity. They were bold declarations of a universe far more complex and dynamic than the Earth-centered model could accommodate. Galileo's findings, meticulously documented in his treatise, Sidereus Nuncius, or The Starry Messenger, sent shockwaves through the intellectual community of his time. This treatise was not just a collection of celestial observations. It was a manifesto that challenged the very foundations of the prevailing cosmological understanding. His revelations placed him squarely at odds with the formidable authority of the Church, which saw his heliocentric views as a direct challenge to its teachings. The controversy surrounding his findings was not merely a scientific debate, but a dramatic clash between the new frontiers of empirical evidence and the deeply entrenched doctrines of the era. Despite the intense opposition and personal risk, Galileo stood firm in his convictions, championing the supremacy of observation and experiment over established belief. His unyielding commitment to empirical evidence and his courageous stand against prevailing dogmas laid the groundwork for a new epoch in astronomy. It was a pivotal moment that marked the transition from a worldview dominated by philosophical reasoning to one guided by observational science, where the truths of the cosmos would be sought not in ancient texts but in the skies above. Galileo's legacy, thus, was not just in his discoveries, but in fostering a scientific methodology that would forever change the course of human understanding. The narrative of human understanding, having been dramatically altered by Galileo's celestial revelations, found its next monumental chapter in the work of Isaac Newton. Newton, a titan of intellect and curiosity, seemed to possess an almost mystical ability to discern the fundamental laws governing the universe. In his seminal work, Principia Mathematica, published in 1687, he laid down the foundations of classical mechanics that would stand unchallenged for centuries. This magnum opus was more than just a book. It was a comprehensive treatise that provided a mathematical framework for understanding the motion of celestial bodies, as well as terrestrial objects. Newton's laws of motion, articulated with unparalleled clarity and mathematical rigor, transformed the study of dynamics. Moreover, his law of universal gravitation, which posited a force of attraction between all masses, revolutionized the way humanity perceived the cosmos. It was an achievement of epic proportions, turning the seemingly chaotic and inscrutable movements of heavenly bodies into phenomena that could be predicted and quantified with astonishing precision. Newton's ability to distill the complexities of motion into a set of simple, elegant laws marked a turning point in the history of science, forever changing how we understand the universe's workings. Newton's work did not just reinforce the heliocentric model championed by Galileo. It took a bold step further by unifying the mechanics of the heavens and the earth. Before Newton, the celestial and terrestrial realms were viewed as operating under different sets of principles. Newton's Principia demolished this dichotomy, showing that the same laws of motion and gravitation applied to both the apple falling from the tree and the moon orbiting the earth. This unification was a profound conceptual leap, illustrating the elegance and simplicity underlying the universe's apparent complexity. It was a unification that resonated far beyond the boundaries of physics, symbolizing the ideals of the Enlightenment. In a world seeking order, rationality, and understanding, Newton's Principia stood as a beacon of intellectual triumph, encapsulating the era's spirit. It embodied the Enlightenment's quest for a rational and ordered universe, where reason and empirical evidence reigned supreme. Newton's synthesis of the celestial and terrestrial under a single set of laws was not just a landmark in scientific thought. It was a powerful metaphor for the intellectual aspirations of an entire age, an age that sought to bring clarity and understanding to the mysteries of the universe and human existence. As the 20th century dawned, a new character emerged on the stage of scientific discovery, destined to revolutionize our understanding of the cosmos: Albert Einstein. At the time, a seemingly unremarkable clerk in the Swiss Patent Office, Einstein's extraordinary intellect and boundless imagination were preparing to transcend the traditional boundaries of physics. In 1905, he published his special theory of relativity, a groundbreaking work that dramatically altered our conception of space and time. This theory proposed that space and time were not distinct entities, but interwoven into a single fabric, space-time, and that this fabric was influenced by the presence of mass and energy. His theory challenged the Newtonian notion of absolute time and space, introducing a universe where time could dilate and space could contract. But it was Einstein's general theory of relativity, published a decade later, that truly reshaped our understanding of the cosmos. This theory expanded on his earlier work, incorporating the effects of gravity into the space-time continuum and predicting phenomena such as the bending of light by gravity and the existence of black holes. Einstein's vision of a curved space-time fundamentally altered our perception of gravity, not as a force, but as a curvature of space-time caused by mass and energy. In tandem with Einstein's revolutionary ideas, the early 20th century witnessed the birth of quantum mechanics, a field that delved into the bewildering world of the very small. Pioneers like Niels Bohr and Werner Heisenberg stood at the forefront of this quantum revolution, revealing a subatomic realm that operated under rules entirely different from the macroscopic world. In this strange new domain, particles did not have definite positions or velocities until measured. They existed in a state of probability, a concept that defied the deterministic nature of classical physics. Heisenberg's uncertainty principle and Bohr's model of the atom introduced concepts that challenged the very nature of objective reality, suggesting that the act of observation could fundamentally alter the state of the observed. This quantum world was not just a theoretical curiosity, it had practical implications, leading to the development of technologies such as semiconductors and nuclear energy. The quantum revolution, alongside Einstein's relativity, represented a significant paradigm shift, marking the transition from classical to modern physics. Together, these developments expanded our understanding of the universe, from the vast expanse of cosmic space to the enigmatic behavior of subatomic particles, and laid the groundwork for the technological advancements that would define the century. The expedition of human understanding, stretching from the intellectual curiosity of Aristotle's ancient Greece to the groundbreaking revelations of Einstein's relativistic universe, has been a remarkable odyssey through the ages. This journey, marked by an unrelenting pursuit of knowledge, reflects humanity's intrinsic desire to decipher the mysteries of the cosmos. In ancient Greece, Aristotle laid the foundations with his philosophical inquiries, contemplating the natural world and its workings, setting the stage for millennia of scientific exploration. As history progressed, each era brought with it new discoveries and insights, each a crucial stepping stone in our quest to understand the universe. The Renaissance, with its fusion of art and science, catalyzed an unprecedented expansion of human knowledge. The scientific revolution further accelerated this quest, as figures like Galileo and Newton challenged long-standing beliefs and fundamentally altered our perception of the cosmos. This journey of discovery has been anything but linear. It has been a tumultuous and exhilarating adventure, one that has repeatedly reshaped our understanding of the world around us. As we stand at the threshold of new discoveries, on the brink of unraveling further mysteries of the quantum realm and the vast expanse of space, we are reminded that our quest for understanding is an ever-evolving saga. Each answer we uncover leads to new questions, each discovery a gateway to further mysteries. The journey of understanding, which began with the inquisitive minds of ancient philosophers, continues unabated, driven by our insatiable curiosity and our relentless desire to explore the unknown. The dawn of human understanding, it appears, is merely the beginning of a much grander and more intricate voyage. A voyage that promises to take us to new frontiers of knowledge and understanding in the cosmos. If you enjoyed this video, please subscribe to the channel for more extraordinary explorations of life's most impressive stories.